Hello, greetings, and welcome. Let's take a look at our first example problem from week 7. So in week 7, we'll look at problems from chapter 3 on multi-objective programming and chapter 4, integer programming. So in this specific example, this will be from chapter 3, and specifically it'll be on material related to goal programming. Okay, so in this screencast, we'll set up our goal programming problem, and we have two parts that we'll consider. And then we'll have a separate screencast in which we go ahead and solve this using LibreOffice Calc or Microsoft Excel. So let's go. So TopAd, a new advertising agency with 10 employees, has received a contract to promote a new product. The agency can advertise by radio and television. And the following table gives the number of people reached daily by each type of advertisement and the cost and labor requirements. Okay, so we're given the exposure in millions of people per minute, the cost in thousands of dollars per minute, and assigned employees per minute for radio and television. And then we're told the contract prohibits TopAd from using more than 6 minutes of radio advertisement. If possible, radio and television advertisements need to reach at least 45 million people. So there's our if possible keyword for a goal constraint. Then we're told that TopAd has a budget goal of $100,000 for the project. How many minutes of radio and television advertisement should TopAd use? All right, so let's do it. The first thing I'm going to do to help me feel my way through the problem is define our variables. Okay, so I'm going to start by defining our variables. Okay. And so we're told that we want to solve for how many minutes of radio and television advertisements we should use. So I'm going to let x1 be the correspond to the minutes of radio that we'll use. And I'll let x2 correspond to the minutes of TV or television used. Okay. Cool. Then in terms of setting up my goal programming problem, the first thing I'm going to do is I'm going to go through the problem. So I'll reread the problem, and I'm going to list out my absolute constraints. I'm going to list those constraints that need to be satisfied. And then after that, we'll list out our goal constraints and then use that to set up our objective function. All right, so going through the problem, the first thing I see is that we have 10 employees. Okay, so we have a constraint on the labor available. And so when I look at the table then, so for each minute of radio, we need to assign 1 employee, and for each minute of television, we need to assign 2. All right, so here's our first constraint, constraint on our resources available. And so how I'm going to write this out, right, again, is so for each minute of radio, I need 1 employee. For each minute of television, I need 2, and I have 10 total employees. Okay, so I'm just going to make a note. This is my labor constraint, and so it's going to be x1 plus 2x2. And I'm going to write it as less than or equal to 10. All right, we have 10 employees available, so we can use less than the 10 employees in theory, but we can't use more than them. All right, you might say that we want to use all of our employees, so you might just set that equal to 10, and it would make sense, right? Since radio would just use 1 hour, but I'm going to leave it as a less than or equal to, and we could always visit it later on. All right, so I'm going to make it more general rather than more restrictive by setting it equal to an equality. And I guess my argument would be I'm not told that I need to use all 10 employees, so I'm going to keep it as a less than or equal to. All right, looking for our next absolute constraint. Okay, if we keep reading, we see it here. It says the contract prohibits TopAd from using more than 6 minutes of radio advertisement. Okay, so we're told that the minutes used for radio advertisement needs to be less than or equal to 6. Right? I can use at most 6 minutes of radio advertisement. So maybe I'll call this radio max. Okay, so our absolute constraint that we can use, we can't use more than 6 minutes of radio advertisement. Then looking through, I don't see any more absolute constraints. So next we'll transition to our goal constraints. Okay, and so the first one I see has this keyword if possible. So we're told if possible, radio and television advertisements need to reach at least 45 million people. So if possible, radio and television advertisements need to reach at least 45 million people. So if I go to the exposure row, okay, for each minute of radio, I'm exposed to 4 million people. For each minute of TV, I'm exposed to 8. Okay. So what I'm going to do with this goal constraint is first I'm going to write it down as a constraint as normal. Right? So we want to reach at least 45 million people. Okay, so we'll call this my exposure goal. Okay, I'm going to call it 1, just so you can see when I introduce some deviation variables. Okay, but my exposure goal is 4x1. So for each minute of radio, I'm exposed to 4 million people, plus 8x2. Right, I'm going to make sure I've got it right. For each minute of television, I'm exposed to 8 people. Okay, and we want that to be greater than or equal to 45. Right, our goal is to be exposed to at least 45 million people. Okay, so our goal is to reach at least 45 million people. Okay, great. Okay, so now what I'm going to do next is I'm going to introduce deviation variables and rewrite this constraint, this inequality, as an equality. And so how I'm going to do that is I'm going to rewrite it as 4x1 plus 8x2, okay, plus, I'm going to write it as d1 negative, deviation variable 1, right? So for goal 1, negative, plus or minus d1 positive is equal to 45. Okay. Now we had introduced slack and excess variables back in chapter 2. Here, when we introduce deviation variables, essentially you're introducing both your slack and excess variable. Okay, and what we have going on here is we will still imply our non-negativity constraint, so that all of our variables need to be greater than or equal to 0. Okay, and so we have 2 variables here then, since they can only be positive, to count for cases of when, in this case, our exposure is greater than that goal of, or that threshold goal of 45 million, and then also deviation variable counting for when we're less than that goal threshold of 45 million. Okay, so we need to have both so that we can account for either situation happening. In the constraint case, where say here we would have an excess variable back in chapter 2, it's because this is a constraint, this is our absolute constraint that must be satisfied. So either we'd have an excess variable that could either be 0 or positive, but being less than 45 isn't an option. Okay, so here it's a possibility, right? 45 million is our goal, right? It's not an absolute constraint. All right, so now to put these variables into context. So first, if we look at the case where d1 positive is 0. So if d1 positive is 0, okay, and then d1 negative is a positive value, okay, what does that correspond to? Okay, so if this is positive, I could imagine bringing this over to the right hand side, so I'd have 45 minus some positive number. Okay, and so what that tells me then is that my exposure due to radio and television is equal to some number less than 45. Okay, so this then is going to correspond to the what would we say? It'd be our exposure less than that goal threshold, right? So this would be exposure below our goal, right? So this would be, say, below goal, and let me call it below goal threshold. Okay, so the idea is we want to, so 45 million is kind of our floor, right? So our goal is to be exposed to 45 million people or more. Okay, so 45 million is kind of our zero, right, our floor. So what this means then is if D1 negative is positive, that's going to correspond to how far below my floor I am. All right, how far below my floor I am. Okay, this means I'm below that floor goal of 45 million. Okay, on the flip side, when I look at D1 positive, okay, 45 million is my floor, my goal. So if I imagine D1 negative now is 0, D1 positive then, okay, this could be negative of a positive number. So if I imagine bringing that over to the right hand side, I'll have that the exposure due to radio and television is equal to some number greater than 45. Okay, so D1 positive then tells me how far above that floor I am. Okay, how far above that goal threshold. Okay, so in this case this would be above. Okay, and actually I'm going to write it as below floor and above floor, right? Okay, that's telling me how far below my floor I am. This is how far above my floor I am. Okay, so this is my goal constraint, right? So here I have it rewritten as a goal constraint, and this is going to be very similar to if you had solved problems using slack and excess variables back in chapter 2, only now we need to have situations where we could be, above or below, kind of in this case that floor, where before we would only be at the floor or above. And in terms of my objective function in goal programming, it's going to be a composite function made up of a contribution from all of our goals. And the contribution here, okay, is that I want to minimize, okay, I'm going to call big G1 goal 1, I want to minimize how far below my floor I am. Okay, ideally I'd want this floor variable to be 0, right, because I at least want to be, so this D1 negative, again, it corresponds to how far below my floor I am. Ideally I don't want to be below my floor, I want to be at my floor or above. Okay, so I want to minimize the value of D1 negative. Okay, I want it to be 0. Okay, I want it to be 0, and I want D1 positive, D1 plus to be positive. Right. So most importantly, I want this value to be negative. Okay. So now if we look at our problem, okay, our second goal is that we have the top ad has a budget goal of $100,000 for this project. So we have a budget goal of $100,000. So we would like to spend $100,000 or less. Right? We'd like the amount of money spent to be less than or equal to $100,000. How much money are we spending? Well, here's our cost in thousands of dollars per minute. Okay, so it's $8 per minute, or $8,000 per minute of radio, and $24,000 per minute of television. Okay, so in terms of my next goal is going to be budget. Okay, I'm going to put a 2 in there because this could be our goal 2. So it's $8,000 per minute of radio. So 8 times x1 minutes of radio plus 24 x2, $24,000 per minute of television. And we want that to be less than or equal to our budget goal of $100,000. So I check to make sure I write 8 and 24. And I want that to be less than or equal to $100,000. So again, the next thing I'm going to do in terms of writing out my budget constraint is or goal constraint is I'm going to rewrite this as 8x1 plus 24x2 plus D1 negative minus D1 positive is equal to 100. Okay. And now we just need to look at what this means in the context of this constraint. So where this differs from our last goal constraint is here we have a less than or equal to sign. Okay. So now we kind of have a ceiling, right? So $100,000 is our ceiling now. We want our budget to be at the ceiling or below, right? We want to be below that ceiling. We don't want to be above it. Okay. So now if we look at what these variables mean, okay, so let's start with D1 negative again. So if D1 positive, so these are all going to be positive or non-negative variables, or non-negative. These will all have non-negative values. So if we assume D1 positive is 0, okay, So then D1 negative is some positive number. So if I were to bring that over to the right hand side, I'd have 100 minus some positive number, okay, on the right hand side. And the left hand side would be the amount of money I spent on radio and television. So I'd have the amount of money spent on radio and television is equal to some number less than 100. Okay, so what that tells me then is I'm below my ceiling, right? I spent less than this ceiling dollar amount on advertisement. Okay, so this is good, right? This is our good variable in this case, right? This corresponds to being below our ceiling. Okay, so on the flip side, if we look at this variable, so if we say D1 negative is 0, so now we have minus D1 positive, which is some non-negative variable. And I were to bring that over to the right-hand side, I'd have 100 plus some non-negative variable. So the right-hand side now would be some number greater than 100. So I'd have that the amount of money spent on radio and television is equal to some number greater than 100. So what that tells me then, in the context of my original constraint, is I'm above my ceiling. Okay, I'm above my ceiling. Okay, so this would be above my ceiling. Okay, now I don't want to be above my ceiling. I want to be at my ceiling or below. Okay, so now in terms of thinking about my objective function, our goal is going to be to minimize this deviation variable, which is corresponding to how far above that ceiling we are, right? Ideally, we want that to be 0, right? We would love for that to be 0. So I want to minimize, and I'm going to call it goal 2, D1 positive, okay? And actually, okay, I said I was calling this goal 2. This would be D2 negative and D2 positive. Okay, so I want to minimize how far above that ceiling I am. Okay, D2 positive. Now, if you look back at the problem statement, are we given anything else? No. Okay, so now I have these two goals, okay, or two goal constraints. So with that, then I can write down my objective. Okay, our objective is going to be to minimize, okay, and I'll say Z is equal to G1 plus G2. Okay, so we're going to minimize goal 1 plus goal 2, okay, which corresponds to minimizing Z is equal to D1 negative plus D2 positive. Okay, we want to minimize the sum of those two deviation variables. Okay, so to summarize then, right, we want to minimize. So our objective function is Z is equal to D1 negative plus D2 positive. Okay, and that's going to be subject to, okay, our constraints. Our constraints are our labor constraint, x1 plus 2x2 is less than or equal to 10. Okay, x1 plus 2x2 is less than or equal to 10. x1 is less than or equal to 6. Okay, and then we had our goal constraints. Okay, so it's going to be these equalities here. So we have 4x1 plus 8x2 plus D1 negative minus D1 positive is equal to 45. Okay, and so remember, within our composite, we're trying to minimize D1 negative. Right? If D1 negative is 0, and then we're going to impose our non-negativity constraint. Right? If D1 positive is some positive value, that's great. Right? In that case, I'm above my floor of being exposed to 45 million people. Right? So my goal is, right, so these are positive numbers I'm trying to minimize. Right? So the minimum value of D1 negative is 0. Right? Because my non-negativity constraint. The minimum value of D1 negative is 0. Right? My goal is to get that to as close to 0 as possible. right? And then this would be some positive value, which would be putting me above that floor of being exposed to 45 million people. Okay, so then our budget constraint was 8x1 plus 24x2 plus D2 negative minus D2 positive, and that was equal to 100. Okay. And so again, our goal is to try and minimize the value of D2 positive. Because of our non-negativity constraint, the smallest possible value is going to be 0, right? So we want to get that as close to 0 as possible. D2 negative, I wrote this wrong, right? Yeah, we want to get this as close to 0 as possible. Yeah. All right, and then we're going to have our non-negativity constraint. So now our non-negativity constraint would be x1, x2, and then we have all these deviation variables. Okay, are all going to be greater than or equal to 0, right? And that's non-negativity. Okay, and that's it. So that's our goal programming problem for 1 that we'll go and we'll solve in a subsequent screencast. So our goal is to minimize the sum of D1 negative and D2 positive. So D1 negative, right? So that would correspond to how far below our goal of hitting 45 million people we are. All right, so we want that to be as small as possible. And D2 positive is how far above our budget ceiling of $100,000 we are, and we want that to be as small as possible. Okay, so that's part 1. Okay, so that's part 1. So let me write this as part 1. Okay, so then when I look at part 2, okay, part 2 just asks, Top Ads management has concluded that their exposure goal is twice as important as the budget goal. Update your goal programming problem and resolve. Okay, so now I'm going to add a new page. Okay, so there's not too much that we need to update. Okay, but we're just going to do this. We're going to weight our goals. Right, so we're told that the exposure goal is twice as important as the budget goal. Okay, so all that's going to happen is when I go to my objective function in this case, where are you? Oh, it's because I put the page in the wrong place. Sorry. That's all right. Probably don't even need it. So when I go to my objective is to minimize the sum of goal 1 plus goal 2. Okay, so that's for part 1. Okay, so what's going to change for part 2? Okay, is my objective. Okay, now I need to get it right. So exposure was goal 1. Exposure was goal 1. So for part 2, G1 is twice as important as G2. Okay, so when I define my objective, how I'll do it is I'm going to rewrite this as min, and I'll have Z is equal to, so now I'm going to count G1 twice. I'm going to have 2G1 plus G2. Okay, or min then will be Z is equal to 2, and then G1 was D1 negative plus D2 positive. Okay, so everything else will be the same. Just in my objective function, I'm going to weight my exposure deviation variable twice as much. All right, so if I deviate by 2 units in my if my deviation variable D1 negative is equal to 2, I want it to count in as 4 in this total composite function that I'm trying to minimize. Okay. So that's part 1 and part 2. We'll go and we'll solve this next. Okay. Hope that helps.